L'Hopital's rule has to do with limits. So if you want to define the limit as x approaches a of f of x on g of x. Now if you put a into f of x, then you get 0 over 0. You must have this scenario, you must get 0 over 0. So f of a will be equal to 0 and g of a is equal to 0. If you get that, then L'Hopital's rule says that if you differentiate these two functions individually and then put x equals a in, you'll get what the limit is. So another way to write that is that it's equal to the limit as x approaches a of f dash of x over g dash of x. But you must have 0 over 0 going on when you put a in there. So put a in for x there, evaluate that function, get 0. So you've got to do that first and make sure you've got a 0 over 0 going on. And if you do get that, if you just differentiate each of these and then put x equals a into these two, that will give you the limit. So let's have a look at an example. So find the limit as x approaches 0 of e to the x minus 1 all over 3x squared. Now the first thing I've got to check is that when I put x equals 0 in the numerator, I'm going to get 0 and I'm going to get a 0 in the denominator as well. So x equals 0, you get e to the 0 minus 0 minus 1 all over 3 times 0 squared, and you get e to the power of 0, which is 1, minus 1, and you get 0 over 0. So therefore we can apply L'Hopital's rule. So let's go. So derivative with respect to x of e to the x minus 1. So we've got to find the derivative of the numerator, and derivative of e to the x is e to the x. Derivative of x is equal to 1, so that'll be minus 1, and the derivative of a constant is 0. So find the derivative of the denominator, and the denominator is equal to 3x squared, and the derivative of that, just multiply the index by the coefficient, so you get 6x to the power of 1. So now we can say that the limit as x approaches 0 of e to the x minus 1 over, this is the original question, equals the limit as x approaches 0 of e to the x minus 1 over 6x. That's using L'Hopital's rule. Okay. Once again, when we look at that, we've got a 0 over 0 going on. We put x equals 0 in the top, we get 1 minus 1, and we get 0 over 0. So where do we go from there? We can apply L'Hopital's a second time. So derivative with respect to x of e to the x minus 1. Derivative of e to the x is equal to e to the x. Derivative of a constant, which is negative 1, is 0. And derivative with respect to x of 6x is equal to 6. So therefore the limit, go right back to the original, x approaches 0 of e to the x minus 1 all over 3x squared equals the limit as x approaches 0 of what eventually is the second derivative of the original, and that'll be e to the x over 6. Now we're not going to get 0 over 0 there. We can actually substitute in because we don't have divisibility by 0, so we can put x equals 0. So that'll be all over 6, and that'll be e to the power of 0. Anything raised to the power of 0 is 1, so that'll be 1 over 6. So the limit as x approaches 0 of this original function that we're asked to, you've got to have 0 over 0 going in when you do the first substitution. If not, you can't use L'Hopitals. It'll only work when you get 0 over 0. So indeed we did. So then we actually differentiated the numerator, differentiated the denominator, and then we still had 0 over 0 going on. So we found the next derivative and then put x equals 0 until we got our final limit.